Welcome back to our channel. We shall be talking about inequalities. I want us to first look at this example we have on the board. This is all about equality. It's a 2x minus 5 is equal to 9. That means we have to solve for x. In that situation, 2x, we carry negative 5 to the other side, becomes plus. That's why we have 2x equals to 14. X equals to 14 divided by 2, which is 7. So the same thing applies to inequalities. The major difference is the sign. What are the signs we have? We have signs. We have less than. We have less than or equal to. We have greater than. And we have greater than or equal to. These are the basic signs we have on inequality. So, based on this example now, I can put any of these signs there. It's still the same procedure we are going to follow. Let's take less than or equal to. I have 2x minus 5 less than or equal to 9. So what I need is to just move this negative 5 here. That means 2x less than or equal to 9 plus 5. Then 2x less than 14. We want to find x. Therefore, we divide both sides by 2. Then we say x less than or equal to 14 divided by 2. X is less than or equal to 7. You can see, it follows the same pattern. But the only difference is when you have the issue of negative. For instance, let us look at this example. Before I take that example, let me explain one situation here. If I have negative 3 less than 1, which you all know, negative 3 is less than 1. If I multiply both sides by negative 1, and we have, when you multiply this one, it's going to give me 3. You multiply this one, it's going to give me negative 1. Does it mean I'm going to write 3 less than negative 1? That is not possible. Then, if you cannot write this, it means negative 3 less than 1 is the same thing as 3 greater than negative 1. As you can see now, the sign has changed. What that one tells us is that each time you multiply or divide inequality by negative sign, the sign must change. So, as I was saying, each time we multiply or divide both sides of an inequality by negative 1 or negative number, the sign must change. That is, the inequality sign must change. Let us look at this example. I have 5 minus 2x greater than or equal to 9. Then, there are two ways of solving it. We collect the like terms. It means negative 2x greater than or equal to 9 minus 5. Negative 2x greater than or equal to 4. Here we have negative 2x. It means we are going to divide both sides by negative 2x. But don't forget what I said there. When you are dividing by negative, the inequality sign must change. Then, x will be less than or equal to 4 divided by negative 2. X less than or equal to negative 2. That's one way of solving it. Another way is to avoid this issue of dividing by negative. We have 5 minus 2x less than or equal to 9. I don't want the negative 2x to be here, so I take it away to the other side. That means I have 5 minus 9 less than or equal to 2x. It means negative 4 less than or equal to 2x. What do we now do? We divide both sides by 2. Then negative 2 less than or equal to x meaning that x greater than or equal to -2. Oh, sorry, there's a mix-up. There's a mix-up in the sign. This is greater than or equal to. Sorry for that mix-up. So x should now be less than or equal to 2. So that's how you can avoid the issue of dividing by negative under inequality. We're going to look for more examples, more complex examples, whereby you have variables on both sides. For instance, let's look at this. 2x minus 3 less than or equal to 4 plus 3x. As you can see, we have variables at both sides. So from there we can collect the like terms. Depends on the way you want it. So I will bring the 4 to this side because 3x is greater than 2x. Minus 4 less than or equal to 3x minus 2x. It means -7 less than or equal to x. Then x is greater than or equal to -7. This is how we can solve inequality, just like the normal equality sign. What about if fraction is involved? If fraction is involved, for instance, we have x plus 2 over 3 less than or equal to 2x minus 1 over 2. When you have an equality this way, we call it linear inequality in one variable. You don't cross multiply when it comes to inequality. What you do is you look for the LCM of the denominator. You now multiply both sides of the inequality by the LCM. So when you look at this, you find that the LCM of 3 and 2 is 6. It means I will multiply both sides by 6. I now have 6 multiplied by x plus 2 over 3 less than or equal to 2x minus 1 over 2 times 6. In that case, 3 goes here 1, 3 in this, that's twice. 2 goes here 1, 2 goes here twice. Please don't let us make a mistake. Don't write this. Don't write it this way to avoid mistake, because this one is an expression. Therefore, it must be put in brackets. Less than or equal to, the same thing applies here. We have 3 bracket 2x minus 1. So after that, we open brackets. You have 2x plus 4 less than or equal to 6x minus 3. From there, we can now collect the like terms. 4 plus 3 less than or equal to 6x minus 2x. It means 7 less than or equal to 4x. 7 over 4 when you divide both sides by 4 less than or equal to x, or you say x is greater than or equal to 7 over 4. That's when the linear inequality in one variable is involved in fraction. Though we still have more complex equations which we are going to treat now. Let's look at this example. So find the range of values of this particular inequality. So you can see that this one is a fraction, this is also a fraction. But we can see that this is also a fraction because you can write it as over 1. So this gives us 4x plus 2 all over 2 minus x minus 5 all over 1 less than or equal to 3x minus 1 all over 4. So what you now actually need to do is to cancel the fraction, just like this previous example. To cancel the fraction, you look for the LCM of the denominators. So 4 and 2, the LCM is 4. So everything must be multiplied by 4. It means 4x plus 2 over 2, that's times 4, minus x minus 5 over 1 times 4, less than or equal to 3x minus 1 over 1 times 4. From there, 2 goes in 4 twice. This one remains the same, 4 will go off here. So what we have here is 2 multiplied by this, that is 8x plus 4. That is 2 times 4x is 8x, 2 times 2, 4, minus 4 times x is minus 4x, minus 4 times minus 5, that's plus 20, less than or equal to 3x minus 1. Then we collect the like terms together. So we can say 8x minus 4x minus 3x less than or equal to, this one will go the other side and likewise 4. That's negative 1 minus 4 minus 20. So what do we now have here? 8x minus 4x, that's 4x. 4x minus 3x is x. So x less than or equal to negative 25. That's the range. Any value that is less than or equal to 25 is the range of values of x. So that's one of the complex examples that we can think of. Now, we're going to talk about combining inequalities. That is when you combine two inequalities together in one. For example, if I write A less than X less than B, what that means is that the range of values of X is between A and B. A and B in this case are not included. But don't forget, we can equally have it as A less than or equal to X less than or equal to B, meaning that both A and B are included. But in this case, B is the upper value while A is the lower value. We should bear that one in mind. So we can have a example where an expression will be given in that form. How do we now solve it? There are two ways to it. Let's try to look for one example. Let us look at this. 3 less than x minus 5 less than 7. This is combining inequality. Like I said earlier, there are two ways to it. I can first combine these two, look for x, combine the other one to look for x. Then I can now write as intervals of this format. But without that, we can solve it directly. What we need to do is how to eliminate this negative 5 from here. So if I want to do that, whatever I do to the left side of it must be done to the right side. It means we are going to add 5 to all those two sides. This will become 3 plus 5 less than x, because we have eliminated this, less than 7 plus 5. Then we have 8 less than x less than 12. This is how to work it out. So using the alternative method, in case you may be given a question that will look complicated, it's still the same way. 3 less than x minus 5 less than 7. You combine these two. That's 3 less than x minus 5. From there we have 3 plus 5 less than x, 8 less than x. Also you combine these two. It means x minus 5 less than 7. Then x less than 7 plus 5, x less than 12. So when you combine, when you look at the final result now, 8 less than x and x is less than 12. It means 8 less than x less than 12. So it's still the same thing we are going to arrive at, whichever way we solve it. Let us look at this example also. X minus 4 less than or equal to 2x plus 1 less than x plus 4. In this case, what we need, how to eliminate this x and this one from here. And for you to eliminate both of them, it means you subtract x from here, subtract x from here. Don't forget what I said earlier. Whatever you do to this and this must be done to this. So when I take x away from here, x must be taken away from here also. If you take x away from here, you have negative 4 left there, less than or equal to, I'm taking x away from here. This one is going to remain x plus 1. Less than, you take x away from here, this will be 4. Then, here we have x plus 1. To eliminate this plus 1 is our target now. So we subtract 1 from here. So whatever is done here must be applicable to the other sides. That means you have -4, -1, less than or equal to. When you take 1 away from here, this will remain only x, less than 4 minus 1. In that case, we have -5 less than or equal to x less than 3. So if you use the other method that we discussed earlier, you combine these two and work it, you will eventually get the same answer. So in case, if this one is not clear, you can separate the two, or you say x minus 4 less than or equal to 2x plus 1, 2x plus 1 less than x plus 4. You solve them differently. Here we have -4, -1 less than or equal to 2x minus x. On collecting like terms, -5 less than or equal to x. If you move here, bring this one here, 2x minus x less than 4 minus 1. Then x less than 3. So if you combine the two, -5 less than or equal to x and x is less than 3. All these things can be represented on the number line. For instance, what we just did here, -5 less than or equal to x less than 3. I want to represent this one on the number line. Let's say this is 0. We assume this is 3, and somewhere here we have -5. Just draw a line on that and draw a circle. The same thing here. But how do we now distinguish between the two? This one contains equal to. That means that circle you draw will be shaded. So we now have the two because the two of them can meet. But a situation where the two of them cannot meet depends on what the question is talking about. Let us look at this. If I say -4 less than x and x is greater than 5, I want to represent this one on